Okay, this is Math 1113 Zoom meeting for 8 a.m. in the morning, September 11th. And we will work some problems out of the back half of section 5.1. Okay, and there are some formulas you need to know. Point them out to you. First one, I always remember this form, this length of a circular arc that subtends a central angle of theta. Okay. That language is, so gibberish, but it's basically referring to your standard diagram. If I have a circular arc, and they use S for arc length, and it's found by swinging a radius, R, from here to here, through an angle theta. This is called subtending an arc. And their formula, first formula you need to know, is that arc length is equal to R times that angle. And if you wanted to know, again, the theta in radians only, this is unitless. Radians are a unitless measure. Unitless measure. Whereas the more familiar degrees are a unit. If you wonder where this comes from, well, remember that circumference is equal to 2 pi times the radius for a circle. A circle. This would refer to entire circle. Circumference is all the way around. The angle is 2 pi and the radius is 1. You get a 2 pi all the way around. Okay, so generalize. Call this S. So you stop at an arbitrary point around S. Your 2 pi becomes the angle you stop at, and keep the radius in. And for whatever reason, they like to write the R first in the formula, but it doesn't matter. It's the product of the angle times the radius. So that means S equals R theta. So it's a more general form of your circumference is 2 pi R. Give you some confidence. Why don't we find the arc length halfway around? Find arc length halfway around. So in other words, this would be the top half circle. Top half circle. So your S would equal a radius of 1, and your theta is pi, which means S equals pi. And you've got pi halfway around. There. Okay, before I show you the other formula, let's Start with something like 53. So on page, this is 5.1, page 444, 53. Give you a circle. This is intended to be the center. Looks like you got a line going that way, a line going this way. They're calling this 9. That would be your R. And they're going through 5 pi over 6. Find the length of the circular arc. S. They have it colored in the book. So this is problem 53. They have a red color in the book. 5 pi over 6 for the angle. Radius is 9. And it's really just a plug and chug. S equals R theta equals 9 times 5 pi over 6. Now you can go ahead and punch away and get a decimal. I think the answer in the back leaves it in terms of pi. 3 will go into 6 twice. 3 will go into 9 3 times. So in effect, that's 3 halves times 5 pi. 15 pi over 2. I'll look at the answer in the back. See if they leave it in terms of pi. I believe they do. So this is 5.1, problem 53. Nothing but answers in the back here. 5.1. So here's 5.1, 53. They leave it 15 pi. Oh, we'll give you both actually. 15 pi over 2 and 23.6. Punch away, they're giving the answer to one place. 15 divided by 2. They rounded up to 6. I would have probably written it down as 5, 6, but they're rounding it up to 6 to one place. It's too fast. 23.56, they call it 23.6. Okay, let me kind of show you one way to understand the difference between radians and degrees. If you look at coming up in arc length S, in other words, the question is, what is 1 radian? Have an R through a theta. And we've shown you that S is equal to R times theta. Set the R equal to the theta. I apologize. S. Set the R equal to S. So this means, they show you the other version of the formula here, the theta is equal to S divided by R, because you can divide both sides by R. So an angle is the ratio of the arc length to that radius. If you set the R equal to the S, you can call them either S over S or R over R, either which way you want to substitute it. But you see, if S and R are equal, your angle equals 1. So this is 1 radian. And this is why radians are unitless. If I had 15 meters for S and I had 15 meters for R, the units cancel. I get 1. In other words, at 1 radian, you've gone around the circle. You have gone around the circle a distance equal to the radius. Written out, it's like gibberish, so let me try to show you. At theta equal 1 radian, I meant that to be an arc. Theta here, r. Your s here is equal to the r. So you have gone around an equal distance. S is an equal distance to r at theta equals 2 radians. Theta equals 2, r and s. S equals r theta equals r times 2 or equals 2r. This is equal to twice 2 times the radius times. At 2 radians, your s is twice the radius, and so on. It's also, this conversion is helpful as well. Convert theta equals 1 radian to degrees. 1 radian, and you'd multiply by 180 degrees here and pi here, because pi is automatically radians. All right, well, there's nothing to cancel, so in effect, you're going 180 divided by pi. 57, call it 57.3 degrees. Which means 1 radian, they can go around the circle in terms of radians. And at 1 radian, 57.3 degrees, 1 radian is just short of 60 degrees. It's within 3 degrees of 60 degrees, 2.7 degrees up to 60 degrees. 2 radians, just to try to give you some confidence in this. 2 radians times 180 over pi. You're at 114.6. Notice double 57.3. Well, that's just short of 120. So this is 2 radians. 3 radians times 180 degrees over pi. $171. Call it 89. And notice that's just short of 180. Remember, it's 180 degrees on the x-axis. 3 radians equals 171.89 degrees, just short of 180. And at 180, you're at pi, which means you're at 3.14. Remember your decimal for pi, radians. So notice 3 radians is still short of 3.14. This angle here is 0.14 radian. And so on. That's the top half, and I could keep going around to finish. But let's, we'll work some more problems here. Try 57. They write it down in words. And my My screen is free. Okay, go. Find the, you got to be able to interpret this. Find the length S of the arc that subtends, can't let this gibberish throw you, a central angle of measure 3 radians in a circle of radius 5 centimeters. All right, find the length S of the arc. I just showed you that 3 radians is over here, if you want a really accurate picture. This is pi radians, 3 radians is short. So they want the length of that arc. You're subtending your central angle theta. Theta is 3. Your R is 5. And it's really just plug and chug. Your S is R theta. That's 5 times 3. R is 5. Theta is 3. It's 15. Notice the arc length at 15 is 3 times the length of your radius. 5 at 3 radians. All right. 59 switches the formula up and says find theta. The radius is 9 meters and the arc length is 14 meters. Find theta in degrees and radians. I always start with R theta, but you can see, because I never can remember if it's S over R or R over S, but it's S over R. If you do this, it's obvious it's S over R. But they actually write this form separately in the book if you can remember it, but I always remember this because that tells me instantly it's S over R because you're dividing by the R. All right, and it's plug and chug. It's 14 meters over 9 meters. So, if you want a picture of this, you've gone around 14 meters with a radius, that's your S, of 9 meters. So you can tell it's over 1 radian. If this had been 9 meters, you'd be at 1 radian. You can tell it's over 1 radian. And you see why it's unitless. This is going to come out in radians, 14 divided by 9. .55 or 5.6, either one. I'll call it 5.6 radians. You don't have to put an R. You don't put any circle here. Putting a circle would say it's degrees. It's just a number. All right. So this is radians. If you want degrees, you take 1.56 times 180 degrees over pi. Just leave all the decimals there, times 180 divided by pi. Oh, I'm just short of 90 degrees. 89.13 degrees. Just short of 90. So my picture's a little inaccurate. If you want to be super technical correct here, I should have stopped. 0.13 degrees short of 90. Hard to tell without running the numbers, though. All right, why don't we try something like 61? find R. You have an S equals 15 with a central angle 5 pi over 6. Once again, S equals R theta. So your R, can you tell it's going to be S divided by theta? Tough to memorize every variation of it. So if you remember one version of it, you can easily get to whatever they're asking for. Or you can plug the numbers into this and, divide the numbers and they'll tell you the R. And so the S is 15. They don't give me they do give me a 15 meters. And remember that 5 pi over 6, this is unitless. Now I can divide it as is. Make sure you put it in parentheses. But this will come out in meters. 15 divided by parentheses 5 pi divided by 6. Close. 5.73 meters. All right, when we go to 63, they switch the formula. Go to problem 63. Now they want areas of these sectors. So 63 is up here. Area of a sector. Find the area of the sector. All right, so area formulas. Area of a sector. In effect, it's like an area of a piece of pie. 63, this is still page 440. This is page 445. 63A. $80, and the radius is 8. Your angle is 80 degrees. If you flip back, you will find that's right, if I get full on the screen. It's a half the square of the radius times the angle in radians. They show you the derivation up here. I don't know if it's worth writing down. But your fraction of the angle going around is a fraction of 2 pi. And that's the fraction of the area of the circle you have. And the area of the circle is pi r squared. Pi's cancel. You have theta over 2r squared, and they collect it to 1/2 r squared theta. So that's the formula you need. It's plug and chug. But the important point is theta in radians only. The r squared will be square meters, centimeters, whatever. That's where your units come from. An area has square units. So your units all come from the r squared, not the theta. So in other words, we've got 80 degrees. I need to convert (80°) to radians to use this formula correctly. Now I can do that separately, or I can just do it as part of the formula. That's the way I like it. So I'm going to go 1/2. You've got 8 squared. And when I have 80 degrees, I'm going to multiply that by the 180 degrees down here. So cancel the degree, because degrees are a unit, and put the pi on top. So I can just multiply kind of all at once. But you're free to handle it however you want. If I'd been given, like in part B, they give you 1/2 radian, 0.5 radian, there's no need to do this. So punching away. got a half, I'll call that 0.5. So I'm putting parentheses around the half. 8 squared is 64 times 80. So if I stop here, I get a nonsensical number, and the units are meters squared degrees, or whatever the R is in times degrees. It's nonsensical, so I'm going to multiply by pi, and I'm going to divide by 180. 44.68 square units, whatever they didn't tell the units. Contrast it with B. I think I can squeeze it on. You've got 0.5 radian. R is 10. This is even easier. 1/2 R squared theta. 1/2 times 10 squared times another 1/2, or 0.5. I think it's about 25. Basically, that's a half and a half. That's a quarter of 100 is 25, but I'll just punch away. So I got a front 1/2 in the formula times 10 squared is 100 times another 0.5 for the radius, or for the angle. Yep, 25. So these are not hard problems if you know your formulas. 65 through 69, they don't give you the picture, but it's not really necessary. 65, still off page 445. Find area. Area is 1/2 R squared theta. Your theta, 2 pi over 3. R is 10. I can use that theta directly. 1/2 10 squared, 2 pi over 3. No conversion needed. 0.5, 10 squared is 100, times 2 pi divided by 3. 104.72. '67 switches it up. I have to use some algebra. They're telling me that an area is 70. They give you the units of square meters. The angle is 140 degrees. Find the radius. Well, again, I always start with 1/2 area equals 1/2 R squared theta. I'm going to zero in on that radius here, but I'm going to go ahead and plug and chug the number. I could manipulate the formula, get the formula, then plug the numbers in. You can do it any way you want. 70 for the area there is 1/2 R squared, and the 140 degrees must be converted, or I get nonsensical numbers with nonsensical units. So I multiply that by 180 degrees with the pi here, and that converts it. Now, do this out. I can multiply both sides by 2 to clear the fraction. I can go ahead and 2 or 1/2 there times my 140 times pi over 180. Just get one number over here. Maybe I'll play it that way. So I'm going 0.5, 140 times pi, and divide by 180. 1.22. So then I divide both sides by 1.22. And you can see I need a square root. Square root of R squared, square root of 70 divided by 1.22. I'll just go ahead and punch this all at once. So 70, square root 70 divided by 1.22. Close 7.57. One more that was on the homework. Last one, 69. Page 445, problem 69. Don't tell me you're going to freeze on the last. No, there we are. Thank you. Okay. They give me a radius is 80 miles. Area, 1,600 square miles. Find theta in radians. Once again, 1/2 r squared theta. 1,600 over here equals 1/2 times 80 squared theta. I guess I'll go ahead and get this number, single number, divide both sides by it. I'll have it. So what's 1/2 of 80 squared? 3,200. I almost finished that in my head then. 3,200 theta. 0.5 times 80 squared. Yeah, it's 1/2 a radian. Divided by 3,200. 0.5, or you can leave it 1/2, equals theta. You've gone through 1/2 a radian. That pretty much finishes the homework for 5-1. We'll keep the same Zoom schedule. So we'll have our next Zoom schedule next Tuesday. That would be the 8th. Let's see, Tuesday would be the 15th, I believe, at 8 in the morning. So we will see you then for the next Zoom session. Email me with any questions you might have, and we'll end.